another question here that might give you that kind of opportunity, and either of you could answer this, is related to this concept of what you guys are doing, is this idea of a mixture of experts, MoE. And so we have never been told publicly, but there's a lot of evidence, a lot of rumor that models like the GPT-4 architectures that OpenAI has are what's called a mixture of experts. And that is something akin to what I was talking about near the beginning of this episode, where you have a model that triages requests to an expert. And the rumor with GPT-4, at least the original GPT-4, was that it was a mixture of 8 experts. And so each of those 8 experts, you have, you could, to make things kind of simple, it wouldn't be this simple in reality, but let's say one does math, one does coding, one does translations between human languages. So you have these different experts that specialize in different kinds of tasks. And then when a question comes in that's related to math, it can be routed by some meta model that triages them. It gets sent to the math expert. And that way you're not using all of your model weights. You're saving some cost by having those 7 other experts not need to be used. And they might occupy multiple GPUs each, if we're talking about models the size of GPT-4. And if people want to use these kinds of models themselves, the best known example is Mistral from Mistral, the French startup. And so it seems to me, kind of conceptually, that this mixture of experts idea is related in some ways to what you guys are doing. So it would be great to distinguish, and something, I'm not sure if this is the right time or not. It might not even be, and so I can bring it up again if now isn't. But you mentioned, Mark, catastrophic forgetting and how important that is for when we're fine-tuning these kinds of models. So I'm not sure if that relates to the mixture of experts thing. So maybe I'll just leave you guys to do that first, and then we can come back to the catastrophic forgetting.
You want to go for the MoE stuff? I mean, because I could say, like, first on the MoE stuff, right? Is like, yeah, I mean, MoEs are fantastic, right? MoEs are absolutely, I'm shocked that Llama 3 wasn't an MoE, but I guess they did a very, very good job with dense model. But yeah, mixture of experts is great. I mean, but the MoE concept itself, like, it's not a true, like, 8 experts, this one's great at this domain. Like, it's just the way the pattern works, as far as I believe. Charles, you can keep me honest here, right? That it's not like, okay, you have 8 experts and one's really, really good at, finance, and one's really, really good at coding. Like, that's not how the structure is. So training MoEs is difficult in that sense. Like, it's simpler if you think of it like that, though each expert is really good at one thing, which is more the mixture of agents stuff. If you saw that get released recently, which we're actually cooking something in that space. We're cooking something in that space, more of the mixture of agent side, not the mixture of expert side. But yeah, I'll let Charles talk about it. I probably just didn't say, I said a bunch of nothing there. So
yeah, that was great.
Yeah. So, I mean, a Mistral, for example, it's labeled as 8x7b, and people often take that to mean, okay, there are 8 experts that are, indivisible objects within this that you can reason about as subject experts on something, and that's very much not the case. It's actually that each layer of Mistral, the MLP section is divided into 8 experts, and essentially it's more of like a matrix factorization than a actual explicit separation of knowledge. The architecture, though, did give rise to kind of a cool merging hack, which some people are quite fond of. And I'll be very clear up front here. This is a cool hack. This is not something you should really ever use in production. It doesn't give substantial benefits over standard merging. It's just neat that it works at all. But essentially, when the Mistral model was released, I saw the architecture and thought, oh, cool! You could you could shove 8 Mistral models into a trench coat and say it's a Mistral model, and it would actually work. So in that case, you're taking basically an entire Mistral model and taking the MLP section from that and shoving that into each layer of a Mistral model, and then instead of the the actual trained routing that Mistral gets, which is I'll not get into that yet. basically it's just a approximation based on the latent states from the model when you feed in specific prompts to it to redirect actual subject specific queries like, okay, math questions go to this one, literature questions go to this one. And this is incredibly inefficient and quite hacky, and it's neat that it works at all, but it's not really a technique that I'd recommend actually using.
Nice. So I guess the idea is, so my oversimplification of MoE, mixture of experts, conceptually, maybe that the clarifications were really helpful that you both just provided. But how does this mixture of experts concept relate to model merging and what you do with MergeKit?
Yeah. So one a very specific example is that the way that we know that the way that a couple of these prominent mixture of experts models that have been released open source were trained is through a method called sparse upcycling, where essentially they take a smaller model, like for Mistral, for example. They actually did take 8 copies of Mistral, just identical, and then combine them to this architecture, and then did a full pre-train on top of that for however many trillion tokens. We'll never know, but the technique for that is, you can call it a merging technique, and it is implemented in MergeKit. So if you want to do a sparse upcycling of a model that you have into a larger mixture of experts model, there's a script in MergeKit that you can do that with.
Sparse subcycling. So if I can try to break that down, sorry, say it again.
Upcycling.
Upcycling, sparse upcycling.
Exactly.
And so let me just recap back to you, because this is actually that is a really fascinating technique there, and I hadn't heard of it before. But so the idea there is some key terminology here, and this was, I think Mark said the word dense a little while ago, and so this kind of dense versus sparse is worth mentioning here. So when you have Mark was talking about it in the context of Llama 3. So Llama 3, Llama 2, up until about a year ago with GPT-4, all of, prior to that, all of the LLMs we heard about were dense, meaning that when you make a query of one of these LLMs, of a dense LLM, every single parameter, so if it has 7 billion parameters or 70 billion parameters, whatever, in a dense LLM, every single one of those parameters has information flowing through it in order to generate the response. And so that requires a huge amount of compute. So a sparse model is this kind of mixture of experts approach where instead of needing to activate all of the parameters, you end up only needing to activate a smaller portion. And so it isn't as simple as, and you guys both, I think, know a lot more about this than I do, but we talked earlier about, if you have 8 experts, when you do a call, it isn't like you only call 1/8 of the parameters. It can end up being like half or a quarter or things like that. And if you want to go into some technical detail on that, our listeners might love to hear about it. But
There's a quick answer there, actually. So for Mixtral specifically, they use a top 2 selection. So you'll end up activating 2 out of 8 experts for each token.
Gotcha. So a quarter there, and then plus whatever parameters need to be activated for the triaging model up front. So a little bit more than a quarter. Perfect. And so so those other 6 experts don't get activated. You're roughly getting 25%, maybe 30% of the activations, meaning you're saving about 75% on cost, about 70% on inference time. And so you're getting high quality results faster, cheaper to users, which is obviously something that you love to do, especially when you're working with large language models. So that's the idea of a sparse meaning that in this case, not all of your parameter weights are being activated on a given call to the model. So then this idea of sparse upcycling, did I say that right this time?
Yep.
Is that and this is something that you can do with MergeKit. It allows you to take, say, 7 billion parameter starting point models. It could be a Mistral one, it could be a Llama 3 one, and you just take copies of those with this starting model weights, all identical, but then you fine tune that model on some task, and through this sparse upcycling, you end up fine tuning each of those expert to be expert at different things. and you get those kinds of those mixture of expert advantages once you're in production. Did I get that?
That's pretty much accurate. I will say that this technique pretty much is reserved for the extremely GPU rich. To really get the advantages of training a sparse model, you need to be thinking in terms of trillions of tokens, not millions, which is out of the reach of most people. But for smaller scale models and for larger scale data sets, yeah, it's a very, very useful technique. The actual sparse upcycling and creating true mixture of experts models from scratch is very much reserved for the people with more money than I can count. But I think there's a lot of promise in the the mixture of agents approach, which is sort of a more coarse-grained approach to a similar thing. So I think there's going to be some exciting stuff coming out in that space in the nearest future. We'll see. Yeah. So
Nice.
as far as
And so that idea
sorry,
with mixture of agents, you're less concerned with blending and so they are with a mixture of agents. It is more like that discrete thing that I was describing where you have a
Mhm.
coding model, a math model, a natural language model.
Exactly, yeah. Where you actually have separate models, and each is generating their own separate answer, and that's getting combined,
Mm.
down into one better overall answer.